Good evening, dear all. Today we'll learn about significant figures or digits. Now, in another 2 years, you will be writing entrance exam of JEE, NEET. In that, in some numericals or some questions, you will be required to use significant figures or numbers or digits in chemistry also and physics also. So, very calmly understand what is the answer we get when we talk about significant numbers. Fine. So first let us define significant figures or significant digits. See, when we talk about any measurement, we use an instrument. That instrument has a certain least count, that is the minimum measurement that can be made by the instrument. And that least count determines the precision of that instrument. The precision of that instrument is determined by the least count. Now, what is least count? I said that is the minimum measurement that can be made by that instrument, that is least count. Least count will tell you about the precision that this particular instrument can measure any value only up to so many digits. So let me give you an example of least count where I have a scale which has a least count of 1 millimeter. Correct? Okay. So it can measure up to 0.1 centimeter. So this scale will give me a measurement of say 1.1, 2.5. That is, I will have a decimal only up till only one digit after the decimal. Fine. Then I can consider another scale in which the least count is half a millimeter, which is 0.05 of a centimeter. So with this scale, I can measure say 1.15, 2.25 of a centimeter and so on. That means in this kind of a scale, I can measure up to 2 digits after the decimal point, and in this kind of a scale, I can measure up to 1 digit of a decimal point. So this what I have marked after the decimal point is called the precision of the measurement. So when we are talking about the measurement, we have to report, means we have to write the measurement, report the measurement with the precision of the instrument. Precision will be decided by the least count of the instrument. Okay, so measurement has to be reported with the precision of the instrument, which will be decided by the least count of the instrument. Fine? Okay. Now, once the reporting is done, we have to find out what is or what are the significant figures in it. Okay? So, let us consider with an example how to decide the significant numbers in a particular measurement. So let us go back to this example given 1.1 centimeter. Here 1 is a reliable digit and 0.1, that is 1, is a first uncertain digit, means not sure digit. Okay. Here in the next example 2.5, 2 is reliable and 5 is uncertain. In the measurement 1.15 centimeter, here also I write centimeter, any measurement must have the units. Here 1.1, both are definite, so reliable, and 5 is not so sure whether it is 0.6 or whether it is 4, not sure. Okay, so 5 is unreliable. In the next measurement 2.25, again 2.2 is a sure measurement and 5 not so certain. Whether it is 4 or 6, that's not very clear to the person who is measuring, or some defect in the instrument itself. So, how many numbers are available which are reliable plus the first uncertain digit are the total number of significant figures or the total number of significant digits. Fine. So, in this example, we have 2 significant digits. 1 digit unreliable, 1 digit uncertain. Similarly, here also 2 significant digits. 1 reliable, 1 uncertain. In this case, 2 plus 1, 3. So 1.1. So 2 digits are reliable and 1 digit is uncertain. So how many significant figures does it have? 3. How many significant numbers does this number have? 3, out of which 2 and 2 are 2 digits which are reliable, and the number 5 or the digit 5 is the first uncertain digit. So total significant digits are 3. Another example also can be given, like you are measuring the period of oscillation 1.63 seconds. What should be the answer of the significant digits this number has? First digit is reliable, 6 is also reliable, 3 is the first digit which is uncertain. But the number of significant figures or the digits are 1 plus 1 plus 1, that is 3 significant digits. So now you can define significant digit or figures or numbers are reliable digits plus the first uncertain digit. Okay, so in this way, if at all there is an error in the measurement somewhere, we have to understand that this is the uncertain figure which we have, which has to be added for the total number of significant numbers available to us. Fine? Okay. Now, while making the measurements, we also have to take into account about certain other points. I have noted those points here. Choice of the unit does not change the number of significant digits. So consider a measurement 1.307 centimeters. Okay, that is the measurement with the instrument which has a precision of 3 digits. Fine, okay. And now I write the same measurement in meters. So it will be written as 0.0137 meters. Fine, okay. So what has happened? The digit has changed its place ahead by 2 digits, 1 and 0. But what should I do with the significant numbers? Here, what are the significant numbers? 1, 2, 3 are reliable and the last one is uncertain. So, total number of significant numbers are 3 plus 1 is equal to 4, where 3 are reliable and one of the digit is uncertain. Here also, I start from the first digit which is non-zero. So again I have 1, 2, 3. They are reliable and 7 is uncertain. So how many significant numbers I have? 3 plus 1. 3 digits are reliable, 1 digit is uncertain. So the number of significant figures or digits are 4. Same here. Fine. So here, though the location of the decimal point has changed, it will not affect the number of significant digits. So two things you have to remember, that the unit of the measurement does not affect the number of significant figures. Second point you have to remember, the place of the digit does not affect the number of significant figures or digits. Fine. Now in this number, you have a 0 here, you have a 0 here, you have a 0 just after the decimal number. So what are the rules to be followed while considering the significant digits for 0? So we will go one by one to the points which I have taken from the textbook itself. Fine. The rules for zeros start with all the non-zero digits are significant. Means we have to consider all the digits other than 0. Fine. All the zeros between two non-zero digits are significant, no matter where the decimal point is, if at all. So just like here, we have, again I will write the number 1.307. Here you have a non-zero digit. Here also you have a non-zero digit. But this 0 is between two non-zero digits. So that 0 also becomes significant. Example, suppose I take 2506. The 0 which is available to us, it is between 5 and 6. That's why it is significant. Let I have one decimal point here. Then also 0 is significant in this case because it is between 5 and 6 which are non-zero. Simple. Fine. Now let us move to the third point. If the number is less than 1, the 0 or the zeros on the right of the decimal point but to the left of the first non-zero digit are not significant. So now, first of all, let us consider the example given to us. What is the example already given to us? 0.002308. This is the example given to us. Now here you can see that 2 is the first digit which is non-zero. And the other zeros which are in front of it, if you read it as right left you may get confused, but front of it, they are all non-significant. But there is a 0 in between 3 and 8. That is significant. So if at all I consider a number lesser than 1, then I have to consider only those zeros which are between two digits as significant digit. Another example, let me give you. Suppose I have a number 0.0808. I have so many zeros, but this number is less than 1. Fine. So these two zeros which are in front of 8, which is the first digit, are considered as non-significant, whereas this 0 which is between 8 and another 8 is considered to be significant. So here I have totally how many significant digits? 1, 2, 3. My answer is 3 significant digits or figures. Here how many significant digits do I have? 4. Which are they? 2, 3, then 0, then 8. So 1, 2, 3, 4. My answer is 4 significant numbers, not considering the zeros in front of the first digit 2. So now let us go to the point number 4, which is the terminal or the trailing zeros in a number without a decimal point are not significant. So I will consider the numbers which does not have any decimal point. So here we have an example 1, 2, 3. Then here 1, 2, 3, 0, 0. And then here 1, 2, 3, 0, 0, 0. So in all the 3 cases, I only have to consider the digits and don't have to consider the trailing zeros. What are the trailing zeros? The zeros which are in the last, the terminal zeros, provided my number does not have a decimal. So if the number does not have a decimal, then those zeros which are in the end should not be considered as significant digits. So here, though there are zeros here in this measurement, though there are zeros here in this measurement, they cannot be considered as significant digits. So here in this case, I have 3 significant digits, here also 3 significant digits, here also 3 significant digits, though these numbers have trailing zeros. Fine? Okay? Now, let's go to the last point in which it is said that the trailing zeros in a number with a decimal point. With the decimal point is there in my measurement, are significant. So this given number here has 4 significant numbers. Here 2 trailing zeros are available, but it is a precision, so we have to consider them. Here also 2 trailing zeros are available. We have to consider them, but we don't have to consider the numbers or the zeros which are ahead of the first digit as per the rule 2 here available, because this number is lesser than 1. So both these given numbers have 4 significant digits. Fine. So keep all these points in your mind without any confusion. I will just move and you take a screenshot of whatever is being explained to you. Right? Okay.